Okay, let's move on to question 4. Alright, let me summarize what question 4 is about. Essentially for question 4, okay, it is again a wave equation. Okay, and you are given for this wave equation, the wave speed c is equals to 30. You're given the two boundary conditions at x equals to 0, okay, and at x equals to pi. So in this question, what you're asked to find are the initial conditions. Okay, right. So you're asked to find what is u at t equals to 0, and what is du dt at t equals to 0. Okay, so since it's the wave equation, you can just copy the general solution from the formula sheet. Okay, so this is the general solution, right? And you're told that the wave speed, the c here, is equals to 30, right? So when you put c equals to 30 into the general solution, this is what you get, equation 1. Okay, so all I've done is just put c equals to 30. Okay, now you can start using the boundary condition. Alright, so you can apply the first boundary condition. So I put boundary condition 1, which is u at x equals to 0 at any time t must be equals to 0. I put it into the general solution, equation 1, and then that will give me, okay, so I put x equals to 0, I will get h times j plus kt, right, plus, so I put x equals to 0 here, so cos 0 is 1, so you get a, sine 0 is 0, so it's just 0, right, b times 0 is 0, you have c cos omega t plus d sine omega t. This must be equals to 0. Okay, so how does the left hand side equals to 0 for all values of t? Okay, so as before, you can see that you need h to be 0. Okay, so if h is 0, this term becomes 0, and you also need a to be 0. Okay, so when a is 0, the second term on the left hand side also equals to 0. Okay, so now you can put the values of h equals to 0 and a equals to 0 back into equation 1. Okay, so therefore your equation 1, your solution, becomes, okay, so h is 0 and a is 0. Okay, so it becomes u is equals to ix j plus kt plus b sine omega x over 30 c cos omega t plus d sine omega t. Right? So again, I'm bringing the x and the b. Okay, and that's what I will get. Okay, so I bring the b in, so I get bc cos omega t plus bd sine omega t, and again I call I times j as j prime, I times k as k prime, b times c as c prime, and b times d as d prime. Okay. So now my updated solution is j prime plus k prime t times x plus sine omega x divided by 30 c prime cos omega t plus d prime sine omega so now I'm ready to put the second boundary condition, okay, into my updated solution, equation 2. Alright, so I put my second boundary condition, which is u at x equals to pi is 0.2 sine 15t. I'll put it into my updated solution, equation 2. Okay, what that give me? Okay, so all I have to do is just put x as pi. So k prime plus k prime t. So x is now pi plus sine omega pi over 30 c prime cos omega t plus d prime sine omega t, and this must be equal to 0.2 sine 15t. Alright, so again, this has to happen for all values of t. Okay, right. So you can see that the only term, okay, the only term that I want is actually the sine omega t term. Okay, this has to be equals to sine 15t. Alright, so you can say that by inspection, okay, all these terms must go away. All these terms have to go away. Okay, you have j prime, which is 0, k prime must be 0, and c prime must be 0. Okay, which then leaves you with, okay, d prime sine omega pi over 30. Okay, this d prime times this times sine omega t equals to 0.2 sine 15t. Okay, alright. Okay, so again, you can update your solution. J prime 0, k prime 0, c prime 0. So this term is gone, and this term is gone. Okay. Alright. So to carry on from here, okay, carry on from here, you can then tell that your omega, okay, has to be equals to 15. Right, so your omega must be equals to 15. Okay, and this point 2 must come from d prime times sine omega pi over 30. Okay, and so your d prime times sine omega pi over 30, okay, that must be equals to 0.2, right? This must be equals to 0.2, alright? So what does that mean? You already know omega is 15, so you have sine d prime sine 15 pi over 30 is 0.2. Okay, so sine 15 pi over 30, okay, is actually sine pi over 2, right? So sine pi over 2 is equals to 1. Okay. So this means that d prime is 0.2. Okay? Right? So now you know what d prime is, and you also know K prime is 0. I know C prime is 0. I know D prime is 0.2. And I know omega is 15. Okay, I'll put that into my solution, which is equation 2. Okay, and that will tell you that my U is just, okay, so this term is gone, so it's a sine, omega is 15, so it's 15x over 30. C prime is 0, is gone, so times D prime 0.2 sine omega t is sine 15t. Okay, just clean this up a little bit. Okay, 0.2 sine x over 2 sine 15t. Okay, so remember what the question is. The question asks you to find what is u at t equals to 0 and what's du dt at t equals 0. So now that I've found what u is, I can find what du dt is. Okay, so du dt is nothing but, you bring out the 15 to here, is now 0.2 times 15 is just 3 sine x over 2, so differentiate sine, it becomes cosine. Okay. So now I can answer the question. Okay, I'm going to find this. So therefore, from 3, okay, at t equals to 0, okay, put t equals 0, this is just 0, right? Sine 0 is 0, okay, and therefore from equation 4, du dt at time equals to 0, okay, so you put t equals 0 here, you get cos 0 is 1, so you're left with 3 sine x over 2. These are your two answers for question 4.